Okay, good morning, everyone. I know it's early, it's very early. 8:30 is not easy to do. Also for me, I was here since 7:30, so I do feel you. We do have coffee in the back, so if you need some caffeine, please take it to your seat and relax, because we have to start with our user exchange. And I'm happy to welcome all of you. It's not that many yet, so actually 300 people signed up for this event, and I hope it will be more in the later sessions when we are getting a bit through the day. But anyway, good that you're here. Very welcome from ESA side. This year ESA is hosting the Destination Earth User Exchange. It's actually the 4th user exchange already. And as you saw, the user exchange this year is not only just the user exchange, but we are part of a bigger event, which is called the LPS, Living Planet Symposium, one of the biggest Earth observation symposiums in the world. And it's a great opportunity to bring not only the DestinE community together, but also the Earth observation community. You probably saw this beforehand, the whole week, and as you signed up for this event, we got you free access to the Living Planet. You saved the 100 euros. And I'm sorry if you haven't been there the last 2 days, because we had many sessions already on the digital twins and DestinE. We are on Wednesday. The next 1.5 days will be all about DestinE. This year it's a bit different. We don't do parallel sessions, just one track, so you're not going to miss anything. We have 6 sessions on different topics. We're going to have a panel discussion with the most important people of DestinE, and you can actually ask any questions you want. So please keep that in mind for the next session. And then we're also talking about the extreme digital twin, the climate digital twin. We're talking about data, service, and so on. This year we want to highlight that DestinE is not only technically excellent, but also doing something for the users. You are the users. We hope so. I know many of you are already involved, but we also hope that we can engage even more users this time. So that's why it's a great setting. And the first question I wanted to ask to you is, who has been there for the last user exchanges? Okay, more than half, not too bad, but we do have some more people. We also have attendees online. They can follow the whole day online. You can actually also ask questions via the chat. And we also do have a Slido prepared, also for you in the room. You can scan the code. You can also ask questions with the microphone, of course. We are getting around later. But if you scan it, you can also ask questions via Slido. We will do it. The technical guys will put it on the screen at some point that you can always scan it. Perfect. So what else? As I said, we're going to be in this room for the whole event. We also have the poster session in the back. Many of you already hang their posters. We are providing food and drinks the whole day. So if you're hungry, you can get something to eat. No worries, you don't need to go out. And you can actually also talk to the people who did the posters to engage with them. Now, you can see it on the program here, right? We have a long break between 10 and 11:30. You can join outside, but I would recommend to stay in the room, have coffee, and engage with all the community. We will be here also all the day. We have experts from EUMETSAT, ECMWF, and European Commission. Please approach us, talk to us, and we will be here. So let me check if I forgot something for this. Oh yeah, the most important thing is that we're going to have a reception after the event tonight. So we're going to have some alcohol, some food, some finger food, and can even engage more. And before we start with the opening, I want to thank all of our partners, ECMWF, EUMETSAT, and also the European Commission and all the contributors who are here today, who collaborated with us and gave input to the sessions. I hope it's going to be an interesting day. And with that, we want to officially open the event. And I would like to welcome on stage Nikolaus Hanowski. He's actually head of mission management and the ground segment department at the ESA Earth Observation Directorate. He did a good job in steering ESA's contribution to DestinE, and he's going to welcome you all today.
Good morning. I hope you can hear me. Is that working? It's a great pleasure to have you here at LPS. Again, my name is Nick Hanowski. I'm responsible for the Copernicus Sentinel missions and operations and the Earth Explorer missions and operations, the ground segments, the data management part, and for the programs that are relating to digital twins and foremost on the ESA side, Destination Earth. And again, it's a real great pleasure to see so many of you at this early hour here in the room. I want to start in a different function. I'm also co-organizing of this conference, and I'm just coming out of the daily briefing just to announce that we are on our way to 7,500 registered participants to this conference. If you're also taking into account the students and the children that are being integrated into the activities here, it means that this time Living Planet Symposium is engaging almost or over 10,000 people. I think that's a figure to be digested and cherished. I would make the statement that Destination Earth, that the ambitions of Destination Earth and digital twins in general play a major part in the attractiveness of this conference. I cannot start by opening a session like this one without complimenting, congratulating, and thanking the Commission for having the courage and the vision to start an initiative of that scale with three very different, independent, and strongly profiled entities such as EUMETSAT, ECMWF, and ESA. I think the key statement in any presentation that I'm giving at the beginning is always that we are seeing something quite remarkable in Europe today, and probably ever more important considering the global situation, that there are ways in which European institutions of very different natures can work extremely well together. I think this is not only a signal in terms of organizing the potential of the European communities, the European citizens, and European institutions. I think it's a signal also about how we as individuals can try to work together, even if we have very different backgrounds, or especially because we have different backgrounds, and we'll try to complement each other in the most meaningful way. So I think that configuration in itself is a very important element and driver and motivation in the program. So again, very big thanks to the Commission keeping the orchestration going, keeping the motivation going. I think that's an extremely important part of the equation that comprises Destination Earth. From an Earth observation perspective, because Living Planet Symposium is an Earth observation conference, I'm also regularly repeating, and I'm often asked now by journalists, where does Destination Earth, where do digital twins fit in terms of what it means for Earth observation? And I'm usually enumerating three major paradigm shifts that Earth observation has seen over the last decade. The first paradigm shift was in particular with Copernicus, but also with other programs, that we see such a thing as a global Earth observation endeavor. We are taking measurements of the Earth, we are trying to understand the Earth on a global scale in a free and open data policy environment, and that's, from an ESA perspective, an extremely important element that has led to an exponential growth in the ability to engage user communities that weren't even aware how relevant Earth observation might be. So that was the real first paradigm shift. The second paradigm shift is still ongoing and is something that you will see reflected in the variety and the diversity of the themes at this conference, The second paradigm shift was that we are expanding Earth observation beyond imaging. I think the fact that we are using any type of physical and chemical measurement to understand the Earth, to see how the Earth system components are interacting, are evolving, how they have been in the past, how they are now, and how they are evolving, is a major paradigm shift. We are using technologies that we, a few years, didn't even know whether they would work in space, now routinely to improve our models, our understanding of the Earth system. And from gravity measurements to wind speed measurements to ocean salinity measurements, of course, multispectral and hyperspectral measurements and radar measurements, the whole range of possibilities of understanding and measuring the status and the changes inside the Earth, on the surface of the Earth, and even above the Earth have come into reach. And then there's the third paradigm shift, and I think that's at the heart of what we are looking at here, is that we are moving out of an era where Earth observation in its full range was largely focused on building up records of the past. It's an important task that we are emphasizing and increasing right now because our community's expectation of ESA being able to preserve measurements of the past is dramatically increasing right now. But also to understand the present, to be able to deliver Earth observation data quickly to the user for quick applications, because everything is accelerating. The question of availability of data as fast as possible is ever growing. And now with Destination Earth following the lead of meteorology, climate research, trying to get into the predictive domain. So the word of what we call predictive Earth observation, what-if scenarios, is something that is motivating a lot of communities that are not traditionally linked to meteorology or to climate research, into looking how supercomputing, how the data assets and how the underlying models can be systematically used in order to increase the resolution of predictive scenarios and to increase the range, the diversity of these predictive scenarios. So being fully aware that DestinE is not an Earth observation program and Earth observation is just a component, I think the key message I want to give in this forum, in this context here, is that DestinE is radiating into the Earth observation community. And I hope in the discussions that you're having here from a user perspective, which is the ultimate relevant perspective, you will find among yourselves, but also in the interactions with the rest of the conference, with the rest of the people here, how strongly Destination Earth and how strongly the technologies, the principles, the processes that we are establishing here, in particular bringing the user closer to the system, are relevant for the entire Earth observation domain. And I'm predicting that the next Living Planet Symposium in 3 years will even see a much, much larger focus on this third paradigm shift that I've been talking about. And you can consider yourselves trailblazers, pioneers for opening up a major portion of Earth observation application and context for the future of these conferences as well. So with that, I conclude, and thank you very much for your presence, for your participation, and good luck with the interactions and what you're intending to do. Thank you very much.
Yeah, thank you very much, Nick, and thank you for highlighting that we're in the Living Planet Symposium. That's a great opportunity. And what I also want to highlight is that we have many helpers out there at the booth area. You probably saw we have a DestinE booth, ESA DTE booth, ECMWF, EUMETSAT booth. There are many people also relating to DestinE, so you can approach them. We have presentations there. You can book one-on-one meetings. They will be all around. Usually they're wearing these ESA DestinE polos with the coach on the back. Please approach them. There's many more to see out there. So it's a full program. But all of this wouldn't be possible if we wouldn't have the European Commission taking this risk to fund such an ambitious initiative to build this digital twin of the Earth. We wouldn't be here, and this is very good to have with us Lina Monari. She's actually online today because she couldn't join, but she's from DG Connect, from the European Commission, Unit C1, dealing with high-performance computing and applications. And one of the applications dealing with high performance is actually Destination Earth. And she would also like to welcome you to this event and highlight the importance. Lina, the floor is yours.
Thank you very much. Can you hear me?
Yes.
Franca?
Sorry, yes.
Can you hear me? Yes, very good. Well, thank you very much, Franca. Thank you very much, Nick, our host, Space Agency, this time for this warm welcome and thoughtful introduction, and of all those encouragement to the European Commission that we heard about having taken this initiative and putting it out there. I must say, like, the Commission obviously is very much, of course, very proud of this initiative. And we're also doing our best to support the 3 entities that are actually implementing it. So you're there with the European Space Agency, ECMWF, and in EUMETSAT, and we are the ones, those are the ones to thank for actually what is happening there, and the Destination User Exchange, of course, is that event that brings the implementers but also the users together. So please, I hope you enjoy your time over these 2 days. Unfortunately, our acting director, Gustav Kalbe, was called into another meeting at the last minute, so he couldn't be there with you, and I couldn't be there either this morning. But our team is there on site. Babis, Bertrand, and Marco are all from the DG Connect. So be sure that you find my colleagues and also talk to them directly about your experiences, about Destination Earth and your wishes, because that is also very important. So I would like to, of course, thank Esa and Nick about having organized and hosted us in this event. And it's a fantastic opportunity to showcase Destination Earth during the Living Planet Symposium, as we know, which is one of the premier European forum dedicated to our planet's future, as we would like to call it. We have for this event about 450 registrations. It pales a little bit about Nick's 10,000 attendance, but I think it's very good for a so-called side event to have this many people joining online every year more. And as you heard from Franca, there are 300 participants also registered for the event, and more following online, like me today. So in that sense, I could say that we are at full capacity, which is in a way a testament to this energy, the passion, and the commitment of you, which is the Destination Earth community. So obviously, user involvement is key to the success of Destination Earth, and by sharing your insights and giving us feedback, giving feedback to the 3 entities, going to visit the booth, play around and really be creative around on what we have put there out for you. We would like you to shape the system that addresses your needs heads on, and in a way revolutionizes how we access and use Earth system data and services. So at the end, we need to all ask, why does this meeting actually matter, or this event? So of course, we're all here because we realize that the climate change is a very real threat to our existence. So already, every year is a record year, record temperatures, record floods, record heat waves, record losses. And last year, 24, was actually the warmest year on record for Europe, which was marked by stark contrast. Drought in the east, relentless rain in the west. There was the storm Boris, the devastating floods in Valencia, and other extreme weather events that brought tragic loss of life and significant economic damage, and obviously underscoring the urgent reality of climate change. So these events are a stark reminder of the need to strengthen our resilience, to enhance our preparedness, and accelerate both mitigation and adaptation efforts. So this mission really lies at the heart of the EU's Preparedness Union. Preparedness Union is one of the objectives of the current Commission, and by meeting these challenges demands innovation. And with Destination Earth, powered by the world's most advanced supercomputers, the Euro HPC systems, we are actually setting a global example of how technology can literally help us to respond. So, as you know, Destination Earth is a cutting-edge information system that revolutionizes our ability to simulate, predict changes in the Earth system. We have made sure that it delivers unprecedented detail, quality, and interactivity, and provides authoritative, actionable, precise, evidence-based insights that Europe needs to lead the green and digital transformation. So we are laying the groundwork here for Destination Earth to support a range of key recent EU initiatives, including the Climate Adaptation Mission, Union's Water Resilience Strategy, the European Ocean Pact, the European Climate Adaptation Plan, the so-called ECAP, and the second European Climate Risk Assessment, EUCRA, which is underway. So last year, in a way, marked also my major milestone for us at the DG Connect, and of course for the Destination Earth community, because at that time, Destination Earth became operational and opened up to a large number of users. We actually opened the system in the last user exchange. And today, the platform offers a suite of services, applications for data access, visualization, modeling, and also AI-driven processing. The new applications are in development across key impact sectors such as energy, urban planning, disaster risk management, amongst many others. So in just 1 year, we have built a vibrant user community of over 3,000 registered users. Building on this momentum, we are now actually expanding access to more user groups, in particular EU startups and SMEs that will become users of our AI factories, another initiative that you have certainly heard of, ensuring that the Destination Earth continues to grow and evolve. So we are forging strong partnerships with EU member states and the associated countries, or funding Destination Earth initiative through the Digital Europe program, Europe cities and regions, European thriving AI startups and SMEs, as I already mentioned, very much at the focus of the current Commission and our competitiveness strategy. Today, we are developing innovative tools and applications to support decision makers and policymakers across all impact sectors, because of course, Destination Earth is both an expert system and non-expert system. So we hope that we could bridge this gap between experts and non-expert users through facilitating access to the data, to the services, and to new applications that are possible through Destination Earth. I would like to say something about artificial intelligence, of course, at everybody's lips today. It is also central to Destination Earth's mission, and Destination Earth, in turn, is also poised to accelerate the growth of Europe's AI industry. Commission recently published a new communication called the AI Continent Action Plan. And in line with that plan, we at Destination Earth are soon providing direct access to Destination Earth's data assets for users of AI factories and the AI Continent data labs. So if you haven't heard of those yet, please have a look at the European Commission's AI Continent Action Plan, which is sort of our roadmap ahead in everything we're going to do in AI in the coming years. So our ambition is clear, to harness the latest technologies in support of sustainable policy design and implementation, tackling climate change challenges, and securing Europe's digital leadership at the same time. At the end, still, I would like to go back to what I said earlier, and also what Nick obviously emphasized in his welcome talk. Of all ingredients of Destination Earth's success, one still clearly stands out, and that is engaged and satisfied users. So the user exchange, where you are all today, either online or on site, is our flagship stakeholder event. It's really the unique opportunity to network, to spark new ideas, engage with new users. And so over the next 2 days, I would also like to encourage you to really immerse yourselves to the discussions and connect with your peers, make new connections, and really most of the ambitious program, as we heard from Franca, you will not miss anything. Everything is a one straight program. And so you can really focus on all those things that are there to offer, in addition, of course, to the LPS going on at the same time. So I would like to wish you all very good event. Unfortunately, we can't be there all with you, but technology connects us once again. And I really wish you a successful few days, and I'm looking forward to hear any feedback directly, indirectly through my colleagues and later on. So very successful event for all of you, and I give now floor to Franca to really start the event. Thank you very much.
Thank you, Lina. Thank you. And it's really a pity that you cannot be here. It's really a great event. We had a nice last couple of days. There will be much more to come the next couple of days. You can join online, of course, as the rest of your unit also. And thank you for highlighting the importance of DestinE, also politically. So with that, thank you so much, Lina. Now, I'm really glad to introduce our keynote speaker, and I'm really happy that she accepted, because she didn't want to do it in the first place, but I think she's the perfect person to talk about DestinE and how DestinE can help, because she's part of it from the beginning. She's working with all of us. She has a huge expertise in Earth observation, but also in digital twin and modeling, which is really nice, and I'm really happy that you accepted. And I would like to welcome Anna. She's the Chief Technical Officer of Atlantic Plus. As I said, she has a huge expertise in Earth observation, and she will talk about a nice topic, which is called From Data to Action, using DestinE for resilient and healthier cities. So please welcome Anna.
Hello. So first of all, thank you so much for the invitation. Thank you to the European Commission to putting this initiative together, which is kind of a dream come true to me. Thank you also to the three entities, so ESA, ECMWF, EUMETSAT, for working alongside each other in such an ambitious endeavor. One quick logistic question. Is it possible to tone down the lights a bit, or not really? Just a tiny bit, not too much. We don't have a pointer, right? I need to use the laptop, right? To move the slides. Okay. So, my name is Ana Oliveira, as Franca said. I'm an architect and urban planner by background, and I start by saying this because I don't use the correct lexicon as someone would do if they come from meteorology, climatology, oceanography, or even geophysics and Earth observation and geomatics. So I'm here because I have a dream, just like the American guy said. And this dream is to have healthier cities. And this comes from a deep motivation of having worked for 6 years in the industry and struggled to comprehend how I could design better cities because I didn't have the tools to do it, which is something I strongly believe that Destination Earth can offer. And I think we are starting to see the fruits of this labor. And so basically my presentation today is deeply personal. It deeply goes inside what I have been dreaming for a long while. Even before Destination Earth was there, there were already rumors about digital twin cities as a kind of concept. And this is the kind of vision that I would like to take you with me in this journey. Okay, since I don't have a pointer, I will not travel much inside the stage, but well, the problem, the why. So this was already discussed today. We are facing climate change. Each year encompasses a new record. We have more days of extreme heat. We have extended summer seasons. It should be noted that we still have cold waves, we still have energy poverty, and this is especially worrisome in Europe because we have an aging population. We also have immigrants, which means that the communities are not necessarily well adapted to the future we are facing. And at the same time, coming from Portugal, which is a Mediterranean country, we have been not designing properly our cities. We suffer from what is called coastalization, which is the occupation of our coastal environments. And this urban sprawl, deeply motivated by tourism, often does not encompass the good for the community. It is done based on real estate interests and other kinds of, let's say, motivations. So this means that we are now facing climate change with many risks, from floods, heat waves, with cities that are not as well prepared because they grew too fast and they grew in a suboptimal manner. Whoop, sorry. This was supposed to be an animation? Yeah. So in terms of how this translates into impacts, I think it's also common knowledge as a part of the problem that this translates to consequences. The consequences are not always felt in our skins. I mean, we don't feel the pain when there is a heat wave, but actually a lot of people die. And they die not only because of the excessive heat, but because there is a synergy with air pollutants and other effects. So we suffer from excess mortality, excess hospital admissions. This is something that is very well documented in the literature. Also, psychological health, mental health, I meant. And this means that there is measurable impacts that we see from these kinds of urban planning that we have been implementing in our cities. So this is just to make a case that there are measurable impacts that can be translated into costs of lives and also economic costs. And the reason why this matters is that even though heat waves are synoptic scale regional effects, if we look at the impacts and also the spatial patterns of this, they are not homogeneous in space or in time. In this picture, this is just an example from Portugal for those that are familiar. Even though we have warmer temperatures inland and to the south, which is probably where you go on vacations, to Algarve, the fact is that in relative terms, the coastal north of Portugal is warming faster. And this is because, you know, the ocean is also warming and we are deeply connected to the ocean, the Atlantic Ocean, and this means that even though in absolute terms we are seeing warmer winters, in relative terms the changes are very local specific. So there is this saying that, you know, local scale changes, global scale changes, local scale impacts. And this is seen also in terms of excess hospital admissions, also in terms of excess mortality, and this is just a sneak peek from a publication about excess hospital admissions in Portugal. And as you can see, it's a very complicated picture compared to the previous plot, because actually then we have to overlay the social, economic aspects and the demographics, which is actually what triggers the impact in itself. So it's a function of how well prepared the hospitals are, what's the profile of the population there, how are they prepared to cope with extreme heat. So in other words, we have broader, let's say, hazards exposure. In some cases, they are acute and localized, but the impacts are definitely localized. So weather and climate and Earth observation have been putting the barrier much lower in the sense that we are advancing quite sharply to have a higher resolution scale predictions, predictability, and this is a game changer, as was said earlier. Still, I think there is the need to push the boundary a bit further into local specific exposure and impact, and this is just to make the case for it. So I'm still in the problem, okay? So basically what we have is that we have climate environmental hazards that are local in terms of impacts. The forecasts and projections are not local. Currently they are either global or regional, even though the resolution is becoming increasingly higher. So it's okay regarding the when. It's also okay regarding the where in a broader scale, but it's not okay regarding the why, so the impact in itself and the where this impact occurs. So this means that we need to push the boundaries a bit further. So the user. I already said before, I'm an architect, so this is like my personal profile, my persona as a Destination Earth user. So I'm an architect. I would actually like to identify which areas are likely to face the greatest hazards in the city. I would like to have a tool that allows me to design better and healthier cities. And I like to test this out, to produce scenarios like simulations, like digital twins of a city. And even though at the building scale we do have building information systems that are three-dimensional, at the city scale, we still do not have something that is efficient and that I can play around like my kids play with Roblox or Minecraft. So this is what I want to have, okay? But when I started to go into applied research, which is where I act now in Portugal at the Cola Plus Atlantic, I started to discuss with other people that, like me, have their own needs, their own dreams, their own visions, and I see some synergies and some common ground with them. And because I'm nowadays an hybrid between an architect and, an Earth observation expert, well, it's kind of like I see myself in both sides of the equation. I see myself as a scientist addressing barriers, and I see myself in the side of the user who wants this solution. So I'm trying to bridge this gap because I'm working like if I was working towards my dream, towards myself. And policymakers actually have similar pains, coming from different motivations, of course, because they need to be elected every 4 years, at least in Portugal. So their frustrations are likely a bit different, but the need for a solution for simulation in local scale of the policy impacts is actually there. And this is like, the solution is kind of the same, even if the motivation is different. But I can also talk with researchers and professors and the academia, and now I'm not talking about necessarily the ecosystem of ESA, ECMWF, EUMETSAT, let's say the high-profile academia and research institutes. I'm actually talking about the, let's say, lower-level communities I know in Portugal, so universities that are smaller and in which they want to put this next generation more efficient in handling geospatial data, but they actually need to do the learning curves, steep learning curves. They don't have HPC accessible to them. Often they rely on American solutions, which I'm not going to say the name, but you all know what I'm talking about. And there is a deficit of such a solution at the European level that could provide both the training, the handling, the visualization, and also the predictability, which is the next step, okay? And finally, we should not forget about the wider community. So my father, my mother, the journalist, the media, also the nonprofit institution that is doing and pushing the boundaries in terms of adaptation, or at least pushing for that, but that don't know how to handle Earth observation, modeling, or geospatial data in general. What is a data cube? For them is something that they don't know how to handle. So, well, I think the common ground to this is a Portuguese saying what they want. So myself, like 10 years ago, and all these guys that are represented in abstract terms here. We have a Portuguese saying that is called bom, bonito e barato. In English, this means good, beautiful, and cheap. And even though this is like a very, very, very popular saying, this translates into something that is actually fit for purpose, if you will. Beautiful in the sense that we need to like to use it. It shouldn't be a struggle. It comes to you in an intuitive manner, and it should be cost efficient. So it doesn't have to be cheap in the sense that it's €1 store, but it has to be cost efficient. It doesn't have to be so heavy that we have to wait 1 week, 2 weeks to have the results. So the solution. Now I'm going to show results that encompass like my 5-10 years of work. This is more like applied research endeavor, but please see them as examples of the dream that I'm trying to put you to dream with me, okay? So it doesn't have to be strict to this application. So empirical approach for hazard mapping. So with these advances that we see in Earth observation, climate modeling, weather modeling, and also AI, of course, this means that data-driven models, such as AI, can actually bridge the gap quite efficiently between these lower-level users that don't know how to handle HPCs, large models, large coding pipelines, because we can actually deliver some predictability capacity that can run in 10 minutes. So empirical approach is a very good way of bridging this gap of the efficiency that I talked earlier. At the same time, in terms of cost efficiency, is deeply connected to data-driven methods. So if we have something that is fit for purpose, that is trained on observational data of the impacts, localized impacts, and it is using cost-efficient algorithms, then it's much more efficient and also becomes more smooth to use because it's faster. And then it has to be scalable. And this is where one of the topics that I think Destination Earth brings to the table that I was not possible to deal with in my previous life, which is scalability. So for the first time, we have so many observational data and so high resolution modeling outputs that we actually can start to bridge this resolution gap in terms of the when and the impacts in a much more efficient and straightforward manner, but in a scalable way, because the problem with these localized impacts is that if we replicate for each city at a time, this means that it takes a lot of research and development effort, and in the end, we don't have something that is scalable. But if our inputs are so wide that we can train it fully, I wouldn't say globally, but at least to the European level, then it becomes scalable, the cost drops, and the number of users, of course, likely increases. So it's much more efficient, much more likely to have success, and to meet also standards and goals that are across countries in terms of benchmarking. So basically, yeah. My goal is to have a model for urban planning support in the case of urban health, because urban health is not only about heat, it's also about air pollutants, it's also about green spaces, and to contribute to local climate change adaptation strategies in a manner that is efficient and integrated. So, examples from urban climate, which is quite the easiest for me to show the case in point, let's call it that. So this is a picture for the metropolitan area of Lisbon, and this is the amount of stations that we have there, very few, and this is the characteristics of the urban planning structure. So it's a typical European city. We have a very pretty city center, but it has been aging. It's a first foremost of tourism occupation, so not many people live there. It's very costly to live at the city center, so we see the urban sprawl along the main highways. And at the same time, we see clusters of green patches. Often they are localized, so it's not exactly a green city or a green metropolitan region, but it's not very well observed in situ. What we do have, and we start to having more also in other domains, is citizen observations. So citizens are becoming more aware of these aspects, and this is actually hundreds of stations that citizens like myself and you have in their houses. This comes from a commercial provider in France. I wouldn't say the name because I don't know if I can, otherwise you can ask me. But these are stations that people like my mother, my father have in their backyard or in their houses outside. So using this and data-driven methods, we can actually separate what's good observations from bad observations because we have the reference ones. And even though 50% is garbage, we can use the other 50% to train something. Then at the same time, this is how weather forecasts looks like in Portugal. These are the official weather forecasts, is the Euro model, which Destination Earth now offers something similar at the global level, but this is what I had like 5 years ago. It's 2.5 kilometers in size, and as you can see, there's no city there. These are just blue, orange, red pixels with no kind of land cover, let's say, patches or patterns that you can perceive. But if I put everything together, and if I use in situ observations, in this case crowdsourced data, as my response variable after deep quality control, and this can also be used with Earth observation, okay, as long as we have a long enough time series. We can actually train the model to understand what is the synoptic background condition that can be done with the weather services or climate data that we had available, together with Earth observation data that are proxies for what we know to be the localized hazard exposure. This can also be applied to impacts. So again, this is the concept and the example for you to think about other variables that also can be modeled in this way. So then comes the machine learning and the data-driven methods and the famous AI, because what's good about this is that it can learn these kind of physical relationships in a much more efficient manner, And for the architect, for the policymaker, for the someone from the news, or even from academia or the community at large, they actually don't need the full three-dimensional solving the weather and climate. They just need to understand how this synoptic scale physical modeling, as a function of what is observed localized, becomes something that is the impact. So putting everything together, we then can go beyond the what, the when, and actually understand the where, and have some kind of informed decision making. So what this means in practice is that we come from this, which is the amount of data that I had available at the time, to this, which is a 10-fold resolution increase. It's not only about resolution, it's also about precision. Someone asked me what is the added value. The added value of this resolution increase is not like because it's a very pretty picture, is also because there are significant differences if we look at gradients in cities such as Lisbon, which is deeply connected to the Atlantic and the Tagus estuary. So it means that we can have as much as 5 degrees thermal gradients between inland and near the coast. And at the same time, this means that if we look at the city center, which looks like this, and this is the weather forecast you see behind, so there's no green parks here, we can actually start to have plots like this, in which we see the main development areas of the city. We actually can see the green parks and what is the cooling effect. And if we understand that this relationship is kind of monotonic, and by monotonic I don't mean it needs to be linear, it can be non-linear, but it is you can model it, the relationship between the background conditions and the inner city conditions, then we can start to produce scenarios, which is what we are here for. So what is the impact of this? This is where we are. This is a famous climate stripes that actually this week everyone should have on their LinkedIn or whatever, because it's the climate stripes week, I guess, from Professor Ed Harris. And this is our crossing roads for the future that we have as a possibility, as a function of what's going to be the adaptation and the mitigation measures going forward. So actually, these are our choices from the moment we are at to the future. So in terms of Destination Earth, what does this mean and what does this mean for me? For once, I need to have a very strong and very well-documented historical relationship. And for this, I rely on Earth observation, in situ data, reanalysis, so model outputs, so that I can model relationships from the past. And even though I don't know if these relationships will be withheld in the future, it's the best I can do to actually do some kind of prospects that go beyond temperatures. So this means that if I model the past, and if I prove throughout the past, regardless of the trend, that in a standardized manner there is a strong relationship, even if there is like a confidence interval and some uncertainty tied to it, I can actually have weather forecasts that are better than the ones we have today in terms of the impact prediction within our cities and our metropolitan areas. At the same time, this means that I have a tool, and this tool is the so-called simulation tool that I talked to you about before, to simulate the future and the climate projections at the localized scale. And for this, I can then see, as a function of our choices in terms of mitigation, how the city will evolve in terms of urban climate, and to test different land use, land cover scenarios. So some examples of this. So this is an ESA-funded project led by DMI. DMI is actually adopting this kind of methodology in their own service. They are offering this to the community. For now, it's an historical endeavor. So this goes to the historical part of the equation I saw before. And we were able to downscale the DANRA, which is the local reanalysis. But what Destination now offers is the possibility to move this forward. And instead of being an historical assessment, we can then apply this model also to Destination Earth outputs, climate DT, extreme ZT, and to have a tool that goes beyond what was the past and offers something that has some predictability capacity. As another example, this is a project, Air for Health. We can employ this kind of methods on other scales and other parameters. In this case, it's air quality. And what you can see in these plots, it's not only the temperatures in the upper level, but you can actually see how to downscale Sentinel-5P and also CAMS according to in situ data to actually translate this into hospital admission impacts, because these impacts are known to be a function not only of excess temperatures, but also air quality exceedances. So again, the same technique, another scale, another result that can be delivered to the community, and we are doing this with the Directorate General for Health in Portugal. Another example is that Destination Earth, for the first time, offers the possibility, because all of this that I've been talking about has been done on a case-by-case manner, because the background synoptic conditions were not in a resolution and centralized in a way that could be replicated. So now, for the first time with ECMWF, we are trying to do this globally. So basically, this is a project that is still starting on. It is part of the AI for Good initiative. And for the first time, we are actually using Naples as one of the case studies for benchmarking the solution in terms of European, strictly speaking, data sets, and those from DestinE to actually do it in Chicago, Cape Town, Santiago, Chile, and see how actually Europe can offer this to a wider community globally and serve as an example. And this is the example from Naples and the crowdsourced data that we have. And for the first time also with DestinE, I actually can have in a centralized way not only the inputs, but also the storage of the model. So this is an example of the collaboration with Delta Twin from Gaia Systems, in which I can actually store my model, run my model. These are actually climate simulations in Lisbon. We also have the weather ones. And I can, in addition to use this as a storage and GitHub-like versioning control, I can actually give some logins to some of my users so that they can just at a click generate these plots and see what is the simulated future for the metropolitan area. And last but not the least, I can go further in time, and this is another example for another Horizon project in which we are collaborating with the Climate DT Consortium to actually go beyond and see the prospects for the future. Again, this is Europe, but whatever models we are implemented are scalable globally, because for the first time, wherever we are putting in it, it's scalable outside of Europe. So this can be a beacon to go beyond what is the European cities to servicing the world, or at least ourselves in European terms. And offer, in the end, the climate scenarios that I've been talking about. So these are climate scenarios for Lisbon, and what you see on the right-hand side in red and green is actually the relative deviation from temperature in the future during a heat wave if I change that land use land cover to a park or, let's say, a dense urban neighborhood. So this is actually the tool I'm seeking for, in terms of urban climate speaking, but there are more risks to model. Okay, so I'm entering the last slides of my presentation. I don't know how I am with time. Can I go? Yeah? Okay. So this is kind of the message for the future. I said before that these kind of examples that I said from projects that are more connected to the ecosystem come as an example for a vision that is a bit broader than the projects in themselves. So you can think about them as pieces of a puzzle, but the puzzle is more ambitious and it's bigger. And what I can see as Destination being offering is the possibility to, put this together, have something that is more ambitious and a kind of nested digital twin network that can go to the local level, because the centralized one offers all the tools that I need to go deep into the localized impact and servicing that I want, okay? So this is what I'm going to present next, is something that I think Destination Earth is actually considering, but you can also think of it as my wish list in the sense that I think Destination Earth can even go further than it is today, okay? So it's kind of a challenge. So completeness and detail. If I want to do something that is meaningful in localized terms, I have to model the relationship. Regardless of being urban climate, hospital admissions, whatever, I need to have completeness and detail. And this means that I have to have a very strong record of reliable historical data. In situ, Earth observations, so direct and indirect observations, are a must-have. And we have to have it in detail. We also need to have the synoptic scale conditions, and these can only be done via the climate and extreme ZT models. On the other side, I want these kinds of inputs that I'm working with to be transparent and trustworthiness, and offer trustworthiness, because I need to make sure that whatever I'm delivering to someone that doesn't know how to assess the quality of the output I'm delivering is something that they can trust. I cannot have a huge amount of false negatives. For example, if I'm talking about a binary impact, I need to have at least a very good F1 score, if you want, to make sure that the impacts are actually predicted, even with a buffer for safety. And this is one of the criteria or wish list that I wish Destination Earth actually even goes beyond what it is today. I know that a lot of effort has been put into this, but I challenge Destination Earth to go even further. And I know people involved are very invested in this, which is to have multivariate harmonized data sets together. And by harmonized, I mean they have to be in formats that are compatible with big scale processing, that are efficient to handle from people that are not software developers with very deep or very low-level coding skills, but these data sets need to be harmonized with each other so that the learning curve to put together impacts and response variables and predictors is not so big that it can only be done during a 4-year PhD. It needs to be faster. And again, you can think about the American solution by which you can actually take advantage of the infrastructure and some kind of post-processing of the data into harmonized formats to train this model much, much faster and to have something at hand easier. So this leads me to infrastructure, which is a debatable topic, I know, but I think this is a must-have, and I think this is acknowledged by all that Destination Earth is actually investing a lot of this. I think it could be even more accessible in the sense that we need to fail a lot to get something right. So if we need to fail a lot, it shouldn't be that difficult to access HPC. It should be a bit easier, at least at some scale that we can test and disregard all the non-good experiences and move to the good ones. And finally, something that is more about the showcasing of the results. So if I'm doing this, and recently I learned some skills on programming and coding and machine learning, so I can actually see myself in both sides of the equation. If I want to show this to my mother, my father, or some decision maker or former architect colleagues, it has to be shown in a way that is intuitive, accessible, and that I can be shared. And if it's cool to visualize and, scroll down, then the better, because they actually want something, like I said before, with the 3 Bs, right? So again, the Portuguese saying, bom, bonito, barato, or good, beautiful, and cheap. And by good, beautiful, and cheap, again, I mean that it has to be meaningful, it has to be right, it has to be trustworthy, it has to be also good to work with, so you have to feel pleasure in working with this data, and you have to feel pleasure in interpreting the results, and it has to be cost efficient in the way that decision makers and localized users, which don't have a lot of economic capacity, can actually implement in practical terms without a heavy burden in terms of budget. So this is the vision I wish that Destination Earth allows me to build in the next years. This is generated from ChatGPT. So this is the city. I present you the digital twin city that I wish I could build in the next couple of years. This is the kind of vision that I have for it. So I wish that my kids will have at hand a digital twin city solution that is federated within Destination Earth, by which they can actually see when they are selecting their next house, because they will come out of my house eventually to study or whatever, they can actually select the neighborhood they are going to live in as a function of the hazards, the quality of the quality of living, and also the environmental quality of the neighborhood and safety. So something that they can actually have in their pockets, something that they can have in their mobile phones, because definitely that's what they will handle. They will not be patient enough to have some 4 years PhDs before they have this in their hands. And if we don't do it, someone else will, okay? So finally, well, my token of appreciation to Destination Earth, because as I said before, I was working on this topic and discussing this topic even before Destination Earth was there, because the urban planning community was talking about digital twin cities as a solution for urban planning. And I think for the first time we have the possibility to build these things in a federated manner that actually allows us to benchmark cities in Europe and, you know, move forward with the global goal on adaptation and also early warning systems, which is something that I guess is globally desirable. And with this, I conclude my presentation. Thank you so much.
Very nice. Thank you, Anna. Thank you for taking us onto your journey. Nice journey, nice things ahead. I hope the city is not only burning in the end. It looked like the JetGPT city is just burning. I hope it will be a brighter future than this, with more green trees and so on. But thank you for also highlighting what you need out of Destination Earth. We are all here, we listened. We hope we can work together to make this possible, and I'm really glad that we have you also in the project and many of the other contractors making everything possible. So let's see where we can go, but thank you for your presentation. Very, very well done. Perfect. So this is the user exchange. You know, people who have been here the last couple, like 3 user exchanges know that we also have to report on our progress, what we were doing in the last. When was the last user exchange? It was actually in November, so it's been, but we're working a lot of making everything happening. So we want to highlight what we did, ECMWF, EUMETSAT, and ESA, and we're going to start with ESA. And we're going to start with a presentation on growing the DestinE platform. And I would like to welcome Katrin Hinze to the stage. She's head of ecosystem development. And she's also the mastermind behind the program management with all of DestinE. And she's going to present what we did with the platform in the last couple of months.
Thank you, Franca. Good morning, everyone. So 9 months passed since the last user exchange when we opened DestinE for user registration. So I want to start with some statistics, what happened since then. So we have more than 3,000 users that have registered on the platform. You can see here that there's a continuous growth of user registrations. We have also the user categories that have registered on the DestinE platform. And as you can see, the major part of the users are still research. And I think at this stage of our initiatives, this is quite to be expected. We have registered users from many countries. I think Italy is winning in this contest in this moment, but we will see the future. And we also have a statistic about the visitors that come to the platform every day. By the way, all these statistics are available on our public dashboard that you find on the platform. In this moment, we have 23 operational services available on the DestinE platform. There is 1 service in beta testing, and 3 services can be already discovered in the coming soon section. But there are many more to come. So 44 services have already made the request for the onboarding. 24 are being integrated, 11 are under evaluation, and 9 have just started their journey and the onboarding. We have selected recently 5 new core services that will start the onboarding in July. And we have also selected 12 advanced applications and services that are starting the onboarding in the next weeks. And tomorrow we will learn a bit more what kind of applications are coming. So phase 2 is for us the phase where we are consolidating the services that have been onboarded at the end of phase 1. So there are a lot of evolutions ongoing, and the users are always well informed about services that are being that are having new releases. We have a public roadmap on the platform where you can see what kind of features are actually planned in the available services. how many of these are currently under implementation. You see also when they are expected to be released. And since we have this roadmap this year, 19 new features have already been released. We have, of course, a help desk that is supporting all DestinE users, and the resolution time is quite good, so you are encouraged to contact the help desk whenever you have any request or issue. You see the majority of tickets of the help desk are about user request, and luckily there are not too many blocking issues that have been reported in the past months. So we have an expanding ecosystem of services for DestinE, and we have a growing user base, but what can they actually do? So we have an example of user journey that I want to highlight today. So it starts with joining the DestinE system. We see how users can engage with what DestinE is offering, and then how they can actually contribute also to the DestinE environment. To join is really easy. There's the registration, which is open and free, and it's quite simple. There's not many information that we are asking you. There are then all the services that you can explore in the service registry. You have groups of services so that you can understand immediately what they are actually addressing. So the first group is to access and exploit the data. Then there is a second group about more advanced applications for DestinE. Then we have the edge services that are specialized services offered from the data lake, for example. And we have the services that are in beta testing and the coming soon section that was seen very quickly. Since 1 week, we also have a Learning Hub available accessible from the platform. So on this Learning Hub, you find a lot of documentation. So when you are very new to DestinE, you go there and find all information about the initiative. You have video tutorials and webinars and so on. You also find on the Learning Hub some demonstrators that are there to give an example what you could actually do on the DestinE platform. And we also have a game that we have introduced now during the LPS, which also serves as an example of kind of interfaces that you could offer with the DestinE platform. So we really look forward to get feedback from you also on this one. Then when you are done with the Learning Hub, you could actually go back to the service registry and look at the advanced applications that are available there. So on this slide, for example, you have some services that are coming out of the use cases that we had in the first phase of DestinE. And I mentioned already before that we have the public roadmap, so you could have a look at the public roadmap, what else the services are working on. And you are really invited, when you are missing any feature in the service that you have discovered, to contribute your ideas, what you would like to see in these services. And you can contribute ideas, or you can also give priority to ideas contributed by the community. So you can vote for some of the ideas. And now we come finally to the digital twins. So you want to access the digital twin data, and there is a dedicated page on the platform that explains everything you need to know to access the data. And we have actually, on our second day, tomorrow morning, a dedicated session that explains how to access the data. There are different ways which have different features. You will learn about this more tomorrow morning. Then once you have accessed the digital twin data, you may want to process it, and quite popular is Insula for this. And if you want to learn more about Insula, there's the webinar, for example, the tutorial, video tutorial available on the Learning Hub. But there are also other sessions at the LPS, also at the booth, that are presenting how to use Insula. Then once you have processed the data, you may consider to build your own workflow. So there's, for example, the Delta Twin service. And we have also for this one tomorrow a dedicated talk that introduces this service. And now that you have your own workflow, you may want to build actually a service out of it that you want to offer to the user community. And you can chain the available core services of the platform to customize your own service. And these are just some of the core services that you could use. There will come many more in the coming months, as I mentioned before. And to have a service that really meets the user needs, you could consider also the co-design methodology that is available for Destination Earth, which makes sure that the service that you are developing is useful, operable, sustainable, usable, and also scalable. And we have an introduction to the co-design also tomorrow. And if you now consider to onboard this service on the DestinE platform, you could contact the technical support of the platform. So this is also available on the platform. And we have an open call that is giving also financial support for the integration and initial operations of your service that is linked here. So now, onboarding a service, you become a contributor to Destination Earth. And as I mentioned before, there are the core services that are available for this purpose. You have the identity and access management that you can use for your own service. There's an operational monitoring dashboard that gives you all the information how your service is doing. There's a user support, which gives support to your users, and the security management. For the infrastructure that you need to run your service, you have the access to pay-per-use infrastructure services, and everything is in a secure, sustainable, and scalable environment. And the onboarding procedure foresees that at the beginning, your service is onboarded in a beta version, so that you invite users to give you feedback how the service is fulfilling their user needs. And you become immediately visible because you are then onboarded in the service registry of the platform. So now you have the possibility to adapt your service to the user feedback that you are getting during this beta testing, and you can collect the user feedback through the help desk or also in the user surveys that are organized. And you can encourage the user community to contribute ideas in the public roadmap that I have shown before. And you can engage with the users through the Learning Hub, organizing, for example, webinars. And you can then, if you see that there's a learning gap for the users, publish, for example, tutorials on the Learning Hub. So now you are ready to fully operationalize your service on the platform. You are on a large and growing infrastructure. You have this infrastructure designed also to be sustainable. And you have the conformity with all the European regulations. And you have available the AI framework that can even bring innovation into your service. The environment is ready to be interoperable with other platforms and with the EuroHPC. So at the end, you will have operational services for actionable information. And now is the moment to scale up. So maybe you have offered the service to a limited community, But being on the platform, you have the possibility to introduce new features into your service and scale it up for an even bigger user community. You have the tenancy management, which will be presented tomorrow. You have the accounting that helps to keep track of the resources that are consumed, and you can leverage the machine learning and AI using the DestinE Platform AI endpoints. So this is then offering continuous innovation for your service, because you don't stop when you have just scaled up. You have more users and can introduce more features. Then you will have even more users and can bring even more innovation to your service, so that you really can have an impact on the users. And this is a summary of what we have just seen before of the user journey on the platform. So the join path is for all the users, and then of course to process data and so on you need to be a little bit more expert, but the Learning Hub is helping you to become one. And then the third track is for service providers. And with this, I can conclude. So if there are any users that want to start this journey, please get in touch with us. We are ready to support. There's also the survey in this moment still available on the platform if you want to give feedback. You have here the link to first register, of course, and then to participate in the survey. And here are all the sessions that are available this week. And as Franka already mentioned before, we have the booth that has also a rich program to dig into specific topics. And with this, I conclude.
Thank you, Katrin. Thank you for taking us with us on the user journey. I hope everything is much more clearer. And this is a good highlight. Please take the survey. It's up on the platform. We need to hear from all of you to improve DestinE. We're a little bit behind with the time, but please stay with us, because we have two more presentations to come. They're very important, and I'm trying to not talk too much, that we have more time. So I would like to welcome Irina Sandu. She's Director of Destination Earth at ECMWF, and she's going to talk about the update on the digital twins. And yes, sorry.
Thank you. Very glad to see so many of you here today, and this is more lightning talk to advertise the coming sessions. A lot has happened in the last 9 months, and this is a rapidly evolving project which really pulls together, and Nick said this very nicely at the beginning, it pulls together the expertise of ESA, ECMWF, EUMETSAT, but it also pulls together the expertise of over 100 partner organizations across Europe in more than 25 countries. And Destination Earth wouldn't be there without the vision and the investment from the European Commission, but would also not be there without the decades of investment in science, technology, and supercomputing in Europe at national and European level, and all the other national initiatives, investment of the European meteorological infrastructure, the national met services, the climate services at national and European level in Europe. So what I'll focus on today is very quickly just a reminder, because there may be some of you which are not familiar with Destination Earth. The role of ECMWF, together with 100 partners in Europe, is to implement the digital twins, and the 2 high-priority digital twins implemented at present are the weather-induced extreme digital twin, which focuses on timescales of a few days ahead, allowing to ask what-if questions in the future of, for example, what specific adaptation measures can limit the consequences of recent and future events. For now, we built an infrastructure, a modeling infrastructure to answer such what-if questions, focusing mainly on past and present events, but the idea in future phases, in phase 3 in particular, is to also look at future extreme events. The second digital twin is the climate change adaptation digital twins, which focuses on multi-decadal timescales. And again, the idea is to explore different scenarios and how the climate can evolve in the future. What are the digital twins? Are they just doing weather and climate predictions? No, the whole point is the digital twins are complementing the existing capabilities at national and European level and are supporting, the idea is to support the institutions which are mandated to protect lives and properties by giving them an additional tool which has enhanced flexibility of simulation and outputs, on-demand production, more frequent updates, allows an integration of the sectoral models in the digital twin workflow, bringing Earth system models and impact sector models together to allow more tailored to produce more tailored information. And they also have, thanks to the Euro-HPC supercomputing facilities, without which, again, destination Earth wouldn't be possible, allows to produce information at more enhanced spatial and temporal resolutions. And Anna talked quite a bit about how that can be useful for supporting, adapting, and responding to climate change and extreme events. So these digital twins really complement existing capabilities and aim to boost our capability to respond to extreme events and climate change. The climate digital twin, it aims to operationalize the production of climate information, building on what we have done over the past decades in Europe in terms and worldwide in terms of weather prediction. In the past 9 months, we focused on maturing the workflows that we piloted in the first phase on Euro-HPC to produce climate information. You can see a beautiful visualization there that you may have seen before, produced by the Barcelona Supercomputing Center, one of our partners, which shows the difference in resolution. In the bottom, you have the climate digital twin simulations at about 5-kilometer resolution globally compared to the current climate projections at about 100 kilometers. The climate digital twin is implemented by a strong partnership led by CSC in Finland, together with partners across 6 countries, and it's relying on 3 global models. Our integrated, ECMWF's integrated forecasting system coupled with 2 ocean models, NEMO and FISOM, and the ICON, the German Weather Service Max Planck Society developed climate model. But again, the digital twin is not only about high-resolution simulations, it's really bringing together in the workflow the models, write the output in a common data format and data governance to allow applications to exploit this data more easily. It has a monitoring and evaluation framework called Aqua. You'll hear more this afternoon. And it also computes on-the-fly statistics to ease the exploitation of this data. And you can see there an image of the wind energy production that is computed from the climate simulations to ease the interpretation of the climate data. What has happened in the last months, you might remember we had a similar slide at the last user exchange where we had the first projections with 2 models, IFS NEMO and ICON. And in the meantime, we produced another one, IFS FISOM, which completes this set that we had done in the first phase and beginning of phase 2. We have also extended the extreme event storylines, which is a type of event, which a type of simulation which allows to replay recent extreme events from 2017 to present. That's the red bar there. We extended this set, and it replays this event in the past, future, and present by nudging the climate models to ERA 5, the Copernicus climate change reanalysis. The simulations are all available on the DestinE platform, and you can go have a look and explore the data. We have also focused on explaining a bit more this type of what so-called storyline simulations, and Jan, who produced this nice animation, it's here today. You can talk to him, and the idea here is really that you can play an extreme event, in this case the Central European floods, the storm Boris in 2024, and the climate model is run in conditions typical of 1950, present day, and a 2 degrees warmer world. And the idea is to see how much more precipitation in this case would have occurred, allowing to contextualize climate change. Another really important aspect is the quality control and exploring quality controlling this data, because this is important to build trust, and exploring its added value. And Kat Grayson from BSc is also here today, and she did this nice comparison of the storyline simulations at 9 kilometers with the data from EUMETSAT, the Spanish Met agency, over the Canary Islands, for several years. And you can see the highest resolution simulations we have today, which are the regional Cordex simulations. You can see the precipitation there, which basically doesn't see the precipitation of the islands, because the islands are so small that the climate model doesn't see them. While already at a 9 kilometer, we capture better these gradients over the islands, and we see actually the precipitation. The bulk of the work in the last year, since the beginning of phase 2, really is this work towards operationalization, mimicking what we have done over decades in weather prediction, which is to pass from a piloting stage to something which is production ready. You do operational production with it, and that includes a huge amount of work of separating the workflows for the continuous evolution, because you have to continuously evolve these models, otherwise they become deprecate. Then you have to have a suite where you have the trialing phase of the new model version that you evaluate its quality, if it's better than the previous version. And then you have what we call at ECMWF the O suite, which is the operational production, which is frozen, it's traceable, it's reproducible, and that guarantees, it gives guarantees that, that the data is robust and quality control. And we have, the Climate DT have managed to do this. You'll hear more again. And we started a new set of complete runs from 1990 to 2040 with the new models, with the O suite at 5 kilometer following the high-resmi protocol, and this should be ready by the fall, beginning of the, end of the year, depending on LUMI and Mare Nostrum 5, which are the two supercomputers in Finland and Barcelona, which are allowing to do these runs at such high resolution. The extreme events, digital twin, it's really like a magnified glass on extreme events. It has global simulations of 4 days ahead, and 4.5 kilometers is done by us at ECMWF. These runs are daily produced on LUMI as well. You can explore them. They're available. And then the regional component, which is done by a consortium led by Météo France, with over 20 Met services in Europe, and it's building again on their crown jewels, which are the regional models, Arome, Harmonia, Arome, and Alaro, but this time pushing the resolution towards 700 to 500 meters, and including the impact sector models. The idea, again, having a flexible system which complements existing prediction systems and supports the National Met Services in their role in particular. And again, they have done a lot of simulations piloted over the past months. You can see there an example, and some of our colleagues from the Extremes DT are here in the room. You will hear more this afternoon. And the idea here is, again, we are working very closely with, together with the National Met Service to explore the quality of this data and to explore its added value. This is a case where they actually triggered over Norway, over south of Norway. There was a strong precipitation event in a region with a lot of infrastructure. That's what you see in the middle slide there. And then there is a comparison of the 500 meter, the 4.5 destination as global run compared to the ECMWF operational forecast and the existing regional forecast. So idea there is again to give additional support to those who take decisions. But these digital twins wouldn't be possible if there would not be a framework, because you can see they encompass many components, Earth system models, observations that I didn't even talk about, impact sector models. They encompass, they are produced on various computers, while in weather prediction we are all used to run at home on our own supercomputer. Here there are different architectures, different computers distributed over Europe. There is the data lake, which stores the data and together with other data, and you'll hear more. There is the DestinE Platform. So you have to enable the voyage of bytes of the digital twins, from the digital twins to the user, and the so-called digital twin engine, which is really a software infrastructure which relies to a large extent to ECMWF software engine. When you see all these components there, and Tiago Quintino is there in the room, you can ask him what all the nice names are and what are they all doing. But the point is that digital twin engine allows to run to orchestrate the digital twin workflows on your HPC, to run them, to process the data into coherent output, to put it on the data bridges, and then to allows an access mechanism. The Polytop, Katrin mentioned this as well. It allows to handle and access the digital twin data. And this is available. This is available through the platform as well, and actually Insula, the Insula service, which is one of the most popular services, I understand, to access the digital twin data, it's also accessing that via Polytop. And in the
please note that the plenary session,
I'm almost done.
Crisis and Earth Action, is starting now in Hall D level -2. The plenary session, the Global Crisis and Earth Action, is starting now in Hall D level -2. Everyone is kindly invited to attend.
So we all have to go downstairs, but I'm almost done, so it's good. Anyway, so what we focused on in the last time, and I think you'll see more later in these last months, is really to create examples. For example, how to access the climate digital twin. And there was the WCRP, the World Climate Research Program, had a global hackathon with many nodes across Europe, and ESA and ECMWF supported this hackathon, and people really accessed. There was quite a sizable team which accessed the data using Polytop and Insula and these examples. And one of the new features that I would like to advertise, which is available since January or so, is that you don't need to extract, you can extract not only global fields, but you can really extract bytes of the data. And we put this nice image there for Babis, where you can extract Greece, you can type Greece, and then you can extract the data over Greece and see how the climate is changing over Greece. Anyway, this is just a quick advertising for the poster session this afternoon. We have a range of new use cases or pilot services in different sectors. The idea being to demonstrate the added value and transform the data, the raw data, into information. And you can see here, one important point here, you can see the mix of institutions, again, from across Europe, including industry, but also Met Services Climate Center, which are the knowledge brokers which are needed to transform this wealth of data into information that can be used for decision making. They play a hugely important role. Finally, these digital twins, you will ask the question, if I wouldn't say, you do just a few runs, where is the uncertainty quantification? These runs are expensive. Yes, that's true. That's why we are also building, thanks to the investment from the European Commission, DG Connect, into developing an AI Earth system model, complementing what we do already at ECMWF for the atmosphere, for the weather forecast. You may have heard that we operationalized ECMWF's artificial intelligence forecasting system already a few months ago for the deterministic version, and the first ensemble, operational ensemble AIFS, goes live on 1st of July, will be operational. And in Destination Earth, we complement this by building components for the other Earth system components, the land, the ocean, the sea ice, the waves, and the hydrology, building on the digital twin data and leveraging the Euro HPC capabilities, but also aim to extend towards impact sectors. And the reason why we do this in Destination S is really to support uncertainty quantification, but also easing the interactivity, enhancing the interactivity. And this is just of a pretty animation that we already have the first prototypes of these different components. So finally, I leave you with this final slide, which just repeats what Katrin was saying, that over the past months, we really worked together across the 3 E's to better guide the user on the platform, how to reach to the digital twin data, and there are pages for the extremes and climate twin. We also published a paper. Niels led this paper. Many of you are co-authors. This, again, stresses the breadth of collaboration across Europe, which was just accepted in the Journal of the European Meteorological Society. And we have a range, if you look on the DestinE ECMWF.int website, you can see a range of material which explains more about what the digital twins and digital twin engine are. And that's all I had.
Thank you, Irina. I know all of you are hungry. I'm also very hungry because I didn't have breakfast yet. But we do have a last presentation, and I'm really glad that you stay with us and not going to the plenary session. But the last presentation will be done by EUMETSAT. Lothar cannot be here today. He's actually the program manager of DestinE at EUMETSAT. But we have Danael with us. She's the technical coordinator for DestinE. And I would like to welcome her on stage. And I don't know if you noticed, but it's from a personal level really nice to see that we now only almost have women presenting in the opening session. So a big applause to all of us. And Danael.
Thanks. Thank you, Franca, and good morning to everyone. So today I will present how the data lake, so the Destination Earth data lake component of the DestinE system evolved since the previous user exchange, and it's in its phase 2 phase of DestinE. So taking a step back, I will show you back what is the DestinE ecosystem quite quickly, so and where the data lake stands. Just before, Irina presented the contribution of ECMWF to develop the digital twin models on the HPC infrastructure, as well as the digital twin engine software and the engine. Those are interfacing with the data lake. Also, the data lake interface with the core platform presented just before by Catherine. All the components interact together, but now I will give a focus on the lake. Here, 2 images. The one on the left side is what's of the interaction of the data lake. So, okay, with the green boxes of the digital twins model, so with HPC infrastructures, but also with the orange bubbles, which are other data providers from different data spaces, where the data lake federates with. On top of this, the data lake provides services to take advantage of those data and create additional information. This is based on, the data lake is based on 4 pillars. So this is a framework for collocating OpenStack cloud computing next to the HPC to optimize edge data access and edge processing with the services. This gives access to the unprecedented model resolution of the 2 first twins presented just before, and which will be more presented this afternoon. Also, it provides a concept to federate with the different data spaces, the orange bubbles, and it supports the EU AI Act. All of this is exposed, the services and the data are exposed to the core platform for the user, for you. On the right side, this is a data catalog. So I mentioned quite a lot already the data, the twins and other. Here is a catalog of it. There will be a dedicated poster tomorrow because you maybe don't see all of it. So it will be back in the back of the room. In short, on top of the federated ones and the DTE, there will be also the possibility for your application developed within DestinE ecosystem to be integrated in the portfolio. of course, it follows some quality gates to be added, but this is a feature which is under the process now. So we have already some requests, and since a few days it's available for user to test. And finally, this catalog is not static, but driven for your needs with a new application under development. So we are happy to discuss with you if you identify any gap. Next, what were the key tasks of phase 2 for the data lake? So first of all, we build on previous accomplishments, so to operate, coordinate, and maintain the services and the infrastructure, to enhance the KPI, SLA, and maintain industrial service contracts. Then we mature the services. So we had first delivery in phase 1, and now we have iterative development. So we maintain them and we release new features. They are all operationals. We extend the DestinE data portfolio, as I just said before. This is a data catalog. And finally, the fourth key task is the harmonize and standardize of the services. So we try to provide API based on common used protocols. Here we are using Stack. And we connect with EO data provider, but not only. We also want to connect with statistical data providers such as Eurostat, eventually IoT data, and more. Everything is based on enhancing the near data processing services, evolving the AI/ML preparedness, support integration and interoperability, and support the user engagement. What are the key principles of the lake? So federation over monolithic approaches, interoperability, I mentioned it just before, using well-defined API and commonly used standards. The harmonized data access, so what is it? I've not explained it yet. The harmonized data access consists to give a unique way with a unique ID, credential, let's say, your DestinE ones, to access to the catalog, whatever the data come from. So the SAPI relies on the API of the providers. So we do not transform the data at HDA level, but we harmonize the way to access it and download it. Finally, we support the paradigm of bringing user where are the data, because, and this is facilitated by the distributed infrastructure of the data lake. You will see later where the infrastructure is. So we build the service around the data. You can instantiate the service at any place to avoid a massive data transfer. We give the processing capabilities close to those places, and at different level, infrastructure as a service, function as a service, etc. The last 2 points is we do try to use commonly used technologies to avoid vendor lock-in, and we favorite open source. The services provided to facilitate the to process on the edge, or the bottom one with the black box. This corresponds to different levels. There is a stack, which Jupyter Hub ecosystem providing distributed capabilities as well. The islet compute and islet storage, it's infrastructure as a service. It allows you to manage your environment. And finally, hook function as a service. I won't detail this because there is a dedicated presentation tomorrow morning, early morning. So I invite you to go there and also to speak to EUMETSAT team if you want to know more about it. All those services are on the edge, as I say, on DestinE infrastructure, and thus are restricted to projects responding to DestinE objective. And for this, there is a process to request it. It's evaluated by the European Commission. To do it, there is online documentation, or otherwise just connect to the platform, contact the help desk, and they will get you through the project's mission, we call it. The geographically distributed infrastructure, so there are the data bridge, where infrastructure is giving close to the HPC to host the DTE, the Digital Twin Engine software, and also to store the data. But it goes beyond. It also provides the services close to those place. So where there is Lumi, Leonardo today, and Mare Nostrum as well. HPCs, they are all operational and nominal. The infrastructure of data lake also is close to other providers, such as the EUMETSAT one. At EUMETSAT, we have quite heavy resources, and including quite a lot of AI resources supporting AI and quite heavy AI developments. And Cloud Ferro infrastructure in Poland, which allow to manage the services, and it is what we call the central site, basically. Here, what is the infrastructure growth and the data portfolio growth since the kickoff of DestinE in 2022? In short, so Lumi and Central were operational first in Q3 2023 with 50 petabytes of storage, thousands of cores, GPUs, and we started with 100 datasets, a bit more, and the 2 digital twins datasets. Then we had the Leonardo bridge, which became operational with infrastructure installed there. More storage, more cores, more GPUs, more dataset on HDA. And last, quite recently, Mare Nostrum and the EUMETSAT bridge in Q1 2025. Again, more storage available for the user and more datasets available through the catalogs, through the harmonized data access. At the bottom, you can see a table. Basically, that's the resources provided by DestinE Data Lake, and quite some of them are available for user to develop applications on DestinE. The services presented stack, highlight, hook, or on the request. We opened the process at the beginning of this year. Here is a distribution of the requests we received so far. Please continue to see the map with more colors. And here we can see there is quite a number of requests every month, and I hope it will grow after these 2 days. We already received some after Monday, Tuesday, so quite happy about that. My last 2 slides are on the AI developments done on the lake. So there is an AI-ready data development under procurement, and it is currently under the evaluation. It will be developed quite soon, kicked off probably the next days or weeks. This is a Python framework to prepare analysis-ready data based on the data catalog, so which include a wide variety of data, going beyond EO to allow data fusion, create new applications, etc. And the last 3 points are we provide and we support AI-ready infrastructure with the infrastructure as a service, the ILET service, close to the HPC, and providing some GPUs on request, AI model development to support the development of medium and small scale machine learning methods. And finally, we support the development of AI models to facilitate execution of inference. We have some development in those respects. One of them will be presented tomorrow as well in the morning session. Finally, how the DestinE ecosystem can interact with the AI Factory initiative from the Commission. You can imagine you're like a research center, and you can benefit from both initiatives. Thanks to the destinationers components and where the services are deployed, you can benefit from both of them because of the proximity with HPC systems. And then you can respond to the AI strategy defined by the European Commission, and which was briefly introduced earlier as well. I will conclude on this one. Thank you for staying. And now I will wish you a good break.
Thank you, Daniel. A bit over time, but it's fine. We're going to have a long break now until 11:30. We'll be back at 11:30. Food, drinks are in the back of the room. And a big applause to everyone being part of this opening session. Thank you.